Okay, so real quick I'm going to try and go through the TCA cycle. So for this you just have to remember that it's not as easy, or it's not as hard as glycolysis. Fortunately, there's really only a couple of compounds that can easily trip you up. So obviously first it's pyruvate that you got from the glycolysis pathway. And then pyruvate goes to acetyl-CoA. And then it joins into the cycle. And then you have citrate formed. That's why it's called the citric acid cycle, because you have citrate. Then you have citrate turns into isocitrate. So it's the same word, you just copy down citrate and then put iso because it's the same molecule, just slightly different. The next one's one of the ones you'll just have to memorize. It's kind of hard, but alpha ketoglutarate. The next one is, the next two are quite similar. You have Acetyl-CoA and then succinate. Then you have fumarate, malate, and oxaloacetate. And so that goes around to form this lovely little circle. Okay, so as far as the enzymes and the products of the reaction, the way I remember this is ACE, ACE, DD, synth D, fum D. ACE, ACE, DD, synth D, fum D. Each of these represents one of the enzymes. And then the other thing to remember is you skip the ACEs, and then for these, anytime there's a D, the D stands for dehydrogenase, and I'll explain the other ones real quick, but for any of the dehydrogenases, they're going to be producing hydrogens that will go to the electron transport chain. So you want N, N, F, N. So I just like to remember, do it like this, that the F likes to, this F wants to get in front of this F. And this F doesn't have anything attached to it, but the synth has a G. So I kind of remember this because synth, the Y almost looks like a G. Okay, so what does this all stand for? The N's represent NADH, G is GTP, F is FADH2. So you put it in here. This one's not down here, but pyruvate dehydrogenase is the first one. And then on all of these in the cycle, it's essentially the root word except for citrate to isocitrate. So we'll get there in a second. So to produce citrate, you have citrate synthase. So you have the ACE down here. You could also remember synth ACE, DD, synth D, fum D. But I find that ACE is just nice and clear, and it's easier for me to remember. So, and then citrate to isocitrate. This is kind of the weird one. It's aconitase. And then isocitrate to ice, and like I said, the rest of them, it's essentially just the word. So isocitrate is, we'll look over here. So you have the citrate synthase, aconitase, and then you have D next. So you know this is a dehydrogenase. So this is isocitrate dehydrogenase. So I'm just going to do that. That indicates that it's the same word, dehydrogenase. There's another D. So it's alpha ketoglutarate dehydrogenase. And then you have a synth down here. So you have a Acetyl-CoA synthase. Then you have D, another dehydrogenase. So you have succinate dehydrogenase. And then you have fum, so that stands for fumarase. And then D is another dehydrogenase, so you have malate dehydrogenase. And so that takes you from malate to oxaloacetate, and then you can start the cycle again, going from oxaloacetate plus acetyl-CoA to make citrate. And then as far as the products are concerned, you have NADH coming out here, NADH coming out here, and then you have GTP, FADH2, and then you skip the fumarate step, and then this dehydrogenase produces another NADH. So just as a reminder, going from pyruvate to acetyl-CoA, you go from 3 carbons to 2 carbons. Those 2 carbons join the citric acid cycle and go around, and then you lose carbon dioxide at the first 2 opportunities. So that would be when the first 2 NADHs are produced, you also lose CO2. And that's it.